Hi everyone, welcome back. In this video, we are going to understand spherical polar coordinate system. Okay, this is something very important from you know every perspective. In the classical mechanics, we can't go on without understand the spherical coordinate system. In quantum mechanics, we use this thing in mathematical physics, and in electrodynamics is unsolvable without using the spherical polar coordinate system. So basically, uh, I'll try to divide this spherical polar coordinate system in two parts, part one and part two. In the part one, first we'll understand what is a spherical polar coordinate system, basically how x, r, theta, and phi are connected, y, z with the r, theta, and phi, connected. That would be the first thing. Then we'll try to take some examples. I have taken here certain examples. We'll understand whole spherical polar coordinate system from these examples. Then we'll try to find how to write a given vector in terms of spherical polar coordinate system. Then we'll write the area element is how the different areas are written in spherical polar coordinate system. This will be my plan for this video. Then we'll write the unit vectors of the spherical polar coordinates, that is r cap, theta cap, phi cap, and then we'll try to convert a vector from a given Cartesian coordinate system to the spherical polar coordinate system. I'm damn sure that after watching this video, you won't be confused in any of the question which uses spherical polar coordinate system. Actually, you would be so handy that you would prefer to use a spherical polar coordinate system after watching this video. Okay, let's take these like diagrams one by one, and let's start it. Okay, I just need your 15 to 20 minutes, and you'll feel so confident in spherical polar coordinate system. Let's go one by one. Okay, let's take this diagram. Let's take this diagram. Okay, the first thing that you need to understand in spherical polar coordinate system is that we cannot first thing we cannot define spherical polar coordinate system without Cartesian coordinate. So we have to know the Cartesian coordinates in order to define these spherical polar coordinates. That is why we have x-axis, y-axis, and the z-axis. This one is x-axis, this one is y-axis, and this one is z-axis. Am I okay? So these x, y, and z are the usual Cartesian coordinate axes, and now we'll use these axes to define the spherical polar coordinate system. I have taken a sphere here. So here is the sphere, any sphere of radius some r. So this is a r, it's the radius of this sphere, and I have taken here a point P. Is that okay? So what is the position of this point from the origin of the Cartesian coordinate system? So this origin is for both spherical and for the both Cartesian. So it is like a common point in the two coordinate systems. Is that okay? Okay, so this is the radius of the sphere. This r is same for the every point on the sphere, because every point lies equidistant from the origin of the sphere or from the center of the sphere. Okay, now if that is fine, now there is important point. So first thing, what is r? So basically r is a radius of sphere. Radius of sphere. There is no confusion about that thing. Another point, this point P, it lies on surface of sphere. I'll go a bit easy in this video because some students feel very confused about this system, but I make you sure here that is actually very easy and is actually handy. That's why physicists have incorporated this coordinate system into the physics. Okay, so P is any point, and this r is the radius of the sphere. So every point on the sphere has the same radius. Now there is second thing, there is theta angle, theta, which is actually angle made by r vector. This r vector, okay, this r vector with z axis is fixed. Okay, z axis is fixed as this axis. Okay, and how much angle does this r vector makes with the z axis? That is theta. Okay, so this one is theta, is fixed. That's theta. Now there is third thing, which is phi. This is also angle. So actually in spherical polar coordinate systems, we have two angles. One is theta and another is phi. Some books use some different notations for that. Some use s, some phi, some phi, some t. Okay, but I'll use very simple notation, theta and phi. Phi is what is phi? So basically, I'll first write what is phi, then we'll understand what is phi. So it is actually a plane. It is a plane containing r cos theta and r sin theta. The plane forms an angle, forms an angle phi with x-axis. So this point is very important. The plane, this is actually this phi is angle made by a plane, or simply you can write it is angle made by a plane. Which plane? Which plane? The plane containing r cos theta and r sin theta with x-axis. Again, it's fixed with the x-axis is fixed, so this one is the x-axis. So basically it's an angle. It's an angle made by two projections of r. So now this r has two projections. Okay, one is because we can have any vector and it's having two projections. In Cartesian coordinate system you might have learned, I hope you have learned, if this is some x-axis, this is some y-axis, and we have some vector, this is some vector r, and this is, let's assume this is theta, then x is, like, we can write this r cos of theta and y is r sin of theta. I hope you know this thing. Okay, I believe this is a very fundamental physics. Okay, I hope you know this. Now we have a situation here. Now we have this angle as a theta, this angle as a theta. Okay, now see, so this one since is angle with the z-axis, now here it is y-axis, so here in this case we have here z-axis. Okay, so this one is r cos of theta, this projection, this is r cos of theta, and there is r sin of theta in this direction. Am I okay? Okay, now see, this r, now this r is r, it has angle theta with the z-axis, so r cos theta would be in this direction, r cos of theta. Now you have a choice. This, if this r is in the plane of x, z and y, so like this, then r cos theta would fall on the y-axis. Okay, but we are imagining it more three-dimensional, is a little more conventional, or like more general vector, which lies in the space actually. So this r is somehow there is a point which makes angle theta with the z-axis, and this r has a projection on this plane, xy plane. Am I okay? So r is a vector which makes angle theta with the z-axis. One projection lies on the z-axis, another projection lies on the xy plane. This vector is in such a way, this r vector is in such a way so that its second projection, which is r sin theta, does not fall on this axis, does not fall on this axis, y-axis, but rather that falls on the xy plane. So this plane, so this plane, this plane. So this way is the r sin of theta. Okay, because you can there is a you can resolve any vector in any two perpendicular axes. Any vector, you have some vector here, this is one axis, this is another axis, and like this is perpendicular to each other. I mean, this axis and this axis, we can resolve this vector in these two axes. So r sine theta is the projection of the same vector, r vector, but on the xy plane. Now this r cos theta and now this r sine theta forms a plane. How they form a plane? See, now this is r cos theta. Now see, we can take this r cos theta parallel to each other because we don't have any problem in taking a vector parallel to itself. So this is r sine theta. So we'll move to the second image. So this is now r sine of theta and this is r cos of theta. Let's take this image and understand certain physics here. This is copy. Now let's paste it here. Let's paste it here. You'll understand it more now. Let me erase this one, these whole things. Now see. So this is r cos of theta and now this is r sine of theta. Now this one is theta. Okay, this one is theta. So we can take this r cos theta parallel to itself. So this is r cos of theta. This is r cos of theta and we have this r sine of theta. I can take it parallel to itself. So this is r sine of theta. Now it forms a plane, this plane. Now what phi is? It's a plane, it's an angle made by a plane. Which plane? Which contains r cos theta and r sine theta. So with x-axis. So there is a plane now. This angle is now phi. I hope you got the idea of what is theta and what is phi. So basically theta is simply angle made by the r vector with the z-axis. There is no confusion about that thing. And what is phi? It is the angle made by the plane. Which plane? The plane containing r cos of theta and r sine of theta. What angle that plane makes with the x-axis? Now what are r cos theta and r sine theta? R cos theta is the projection of r vector on the z-axis and r sine theta is the projection of the same vector on not on the y-axis or the x-axis but on the plane xy or simply on the xy plane. So basically two projections are very important, r cos theta and r sine theta. R cos theta is on the z-axis. R sine theta is not neither on the y-axis nor on the x-axis, but it is on the plane of xy plane or simply xy, the plane made by the x and y. So I hope you understand. Now this r cos theta and r sine theta forms a plane if we take parallel properties of a vector into consideration. So the angle made by that plane with the x-axis is phi. I hope you understand. Okay, now there is very important one more important point which is unit vectors. Okay, unit. So basically you have to keep into this consideration this arrow. Okay, this is from the x-axis and that is from the z-axis. Angle made by the r vector with the z-axis but from the z-axis. So this direction is very important. So this is the positive direction. It's a positive direction of theta. So this direction is a positive direction of phi. Just like we take this as the y cap direction, this is the z cap direction, and this is the x cap direction. Okay, we have to take we take this as the minus y cap direction, this the backward direction as the minus x cap direction, and the downward direction as the minus z cap direction. So similarly, so if this is a theta, this direction, the opposite direction, this one direction would be the minus theta cap, and if this is the phi direction, so this direction, the reverse direction like this one, this would be the minus phi cap. Okay. So what is the important point? One more important point. Fourth point is unit vector. Unit vector is in increasing direction of their coordinates. So basically if we unit vector, if this is the theta, so the unit vector in this direction, okay, in this direction, so this direction is the theta cap direction, and the phi cap, the increasing direction of this unit vector is in the increasing direction of their coordinates. So this is the phi cap direction. So let me take it as like it would be a bit backward. So this would be a backward phi cap direction, and there is r, which is simply r cap direction. So increasing order. So I might so we can take it easily from this, we can write it easily from this direction. So basically what I mean by this point is this. So basically this is now r. So if we increasing a coordinate would be in this direction, so this is r cap. I want to be a bit clean because otherwise it will get confused. Okay, so this is r cap direction. Now since this is theta, this is theta, so basically this is, you know, theta cap direction, and this is phi. So basically it goes backwards. So phi is, let me put it here. Actually, let me put it here. So this is phi cap direction. But remember, this phi cap is actually, you know, backwards. Okay, this is what I mean by unit vectors is an increasing direction of their coordinates, and we know this theta cap, r cap, and phi cap, you know, they are perpendicular to each other. I hope you understand this point now. So basically now we came to a bit of conclusion of this very small thing, that this r can have value, this r, where now fifth point. Now this r can have value anything from 0 to infinity, because the radius of the sphere would be anything. So r has value, this is fourth, this is fifth. So r has value anything from 0 to infinity. There is no problem. Now what is theta? What is the value of theta? I mean the range. So see, now there is a very important point. Now since these are the let me put it here, paste. Let me write it here. Let me erase a bit. Let me erase all these things, the things which are not important for me. So basically, if you have this thing as a r, now how much angle makes this r with the z-axis? So this is theta. Now this vector r has same angle with the theta, just the negative of it. And you do one thing, you take the umbrella in the reverse direction. Okay, so the thing is that if we take the part of this sphere, this part, every point makes angle theta with with the z-axis. If you could imagine just like this, this is the top part of the sphere, this is the top part of the sphere, and everything makes angle, every r makes angle theta with the z-axis, because this point and this point is equidistant. Okay, this you don't feel it, but just imagine it. Just opening the just take the umbrella and put it down, and then try to close it. Okay, you see those arrows, you see those those sort of iron rods, small iron rods. So they will make same angle with the z-axis. I hope you are imagining it right now. Okay, so basically this is like that. Every rod makes angle theta with the z-axis. I hope you're able to understand it now. Just if you are now if you close it whole, you are able to close it properly, the umbrella properly closed. So there is simply a line putting downwards. So you're using it to you hold yourself. Sometimes you feel tired and you put your hand on that. So there is angle make the every string of that, or every rod of the umbrella makes angle 0 with the z-axis. So it is closed now. Now if you open it slightly, angle gets increased. So basically when it will properly open, the angle would be 90 degree. Are you able to imagine? So basically initially it was here, then it will increase, 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 increase. So at this stage the umbrella is fully open at this stage, and angle made is 90 degree, or like pi by 2 degree, or pi by 2 radians. Okay, so and let's assume the umbrella has been made in such a way so that it opens in the reverse direction as well. So basically it will open like this, and how much angle you will cover? 180 degrees, you know, or pi radians. So basically theta has the range 0 to pi. Are you able to imagine this thing from the umbrella example? I hope you understand it. So basically the range of theta is basically the range of theta is 0 to pi. Sixth point is because finally if you want to cover the whole sphere, just imagine the umbrella is closed right now, okay, and you're putting it downwards, and basically if you want to cover the whole sphere, you have to go through from angle 0 to pi, then you would be able to cover the whole sphere. Okay, now what is the range of phi? So basically phi, since this is the angle made by this plane with the x-axis, so initially you consider it would be here. So basically it would be here, making how much angle? 0. Then it will come here, how much angle it will make? Phi. Then it increases pi by 2 here, goes back pi, then 3 pi by 2 and 2 pi. So basically just imagine a copy here, this plane as a copy, and you're rotating it from x to y, then y to minus x. There would be a minus x in the backwards direction. So it would cover a pi angle. Then you have to rotate it again towards the negative y. Then from negative y to again a positive x. So finally how much angle you cover? You'll cover 0 to 2 pi in order to cover the whole sphere. Just imagine it here. You're rotating it from here. Initially it was here 0, then it will come here pi by 2, then it will go backwards, then come here, then from here, then you would be able to cover the whole sphere. So phi has 0 to 2 pi. This is a very important point. Fifth point is very important point. Now sixth point is writing the x, y and z. Now see, I'll try to write it from here again. Let me put it here. Okay, sixth point is writing x, y and z. Okay, so see, now I'll write it theta, this is r. Now we don't have any confusion, this is r cos theta, this is r sin theta. Now this r sin theta, this plane is making angle phi with this thing, with the x-axis. So we can write z as simply r cos of theta. There is no problem. And now rx, this r sin theta, this vector is making angle phi with the x-axis. So basically x is r sin theta cos of phi, because any vector, if this is a vector and this is some theta dash, and this axis is r cos theta dash, this is r sin theta dash. So similarly, now this time we have a vector r sin theta. So we have two axes. This is r sin of theta, this is phi. So now this time the vector is r sin theta, and this way it would be r sin theta cos of phi. This is r sin theta sin of phi. So y is r sin theta sin of phi. So this is the relation between the Cartesian coordinates and the spherical polar coordinates. I hope you understand this very important point. Now let's move to the seventh point. I'll make everything in points. Now let's take this image, and now we will try to understand some more pointers from the spherical polar coordinate system. Now see, we have here hemisphere. Now there's a it's you can consider it as a half half an apple, considering okay, half an orange. So half an orange hemisphere, hemisphere fully enclosed inside. Now you see what would be the value of r. Obviously 0 to r. Okay, because everything every point is equidistant from the origin, so r is 0 to r. I hope you understand this. Okay, now see, you have to cover only half hemisphere. So basically this would be theta, these pointers, every point making theta. Initially they would make 0, then increases, and if we'll reach here, how much would be the angle covered? Theta would be 0 to pi by 2. I hope you understand this point. Okay, now third thing is phi. Now in order to cover this hemisphere, you have to rotate through whole 0 to 2 pi, because you have to move from x to y to minus x, then minus x to minus y, minus y to x. Then you will be able to cover this whole hemisphere. Okay, this is some this is some plane. Okay, you have to rotate it, so 0 to 2 pi. Just imagine it, because in order to cover the hemisphere through angle theta, you have to rotate, you have to go from 0 to pi by 2. But in terms of phi, you have to rotate through whole like this. Then you will be able to cover the whole hemisphere. Okay, now in case of the sphere, you understand this. In case of the sphere, you understand this. It's generally for any sphere. Okay, so for any sphere like this, 0 to infinity, like we can go like 0 to infinity. Now if we take a specific sphere, if we take a if we have some general sphere, general full sphere, let me put it like here 8. Okay, if we have this, but rather not like this. Okay, so now that we have this sphere given, so it's given now. I don't want to waste your time much. So this is like, now I hope it's a bit center. So now if it's a given sphere, it's given, so its radius is r, so it's given. So r has a value 0 to r, and if you want to cover it whole, so theta you have to move from 0 to pi. Okay, and in case of the phi, you have to move from 0 to 2 pi. I hope. Now let's take this example. Copy. You have to imagine it, then you would be able to answer very simply. Am I okay? So see, now 6th, 8th, 9th point. So basically if you want to cover this thing, okay, now it's a part, you can consider it as a orange cut down in such a way so that it remains only this part. Okay, is probably the fourth part of orange. Okay, exactly, it's the fourth part of orange. Now you can consider, so rather it's actually 8th part, 1/8 part of orange. So just imagine it yourself. Only part lies between the x and y. Okay, so because it's upper, it lies in the upper part of orange, then it would be 8th part, because the sphere would be whole downwards like this. Okay, so this is only the 8th part. Now if we consider this, so there's a sphere, and we have cut down in such a way so that this remains there. So r, what is the range of r? So it's simply 0 to r, and what is the value of theta? So see, if we want to cover this, so we have it initially, it would be here, then it will increase theta 1, 45, 60 and 90. Okay, then we'll be able to cover whole, because it lies in the above part of the above part of the coordinate axes of this xy. We don't go downwards, we don't go negative z, we don't go in the negative z direction. So 0 to pi by 2. What is the range of phi? So see this surface, it is starting from here. So initially it would make angle 0, then we will go increase here, it will come up to this point and we cover whole thing. So 0 to pi by 2 again. Okay, I hope you understand it. Now let's go to this part. Now let's go to this part. Copy. Now let's paste it here. Now this is the 10th point. Now see, in this example we have taken only this portion, we have taken the dot portion only. Okay, now again tell me yourself, the radius is same, 0 to r, there is no confusion about that. 0 r has the range from 0 to r. It's now the half of the above part of this sphere. So basically range some part of the orange lies inside, and finally it would come to the surface here, and we have 0 to r. Now theta. Okay, now theta has again 0 to pi by 2, because initially it would make angle 0, then increase, and finally it would be 0 to pi by 2. Okay, so now the phi is very important. Now this time the surface is starting from here, not from here. So it was initially it was starting from here. So initially it was angle making 0 with the x-axis. So now this time it is already making angle phi 1, this plane making angle phi 1, then finally it would make phi 2. So phi runs from phi 1 to phi 2. Okay, now I'll take the another example. So this one is gone. Now this example. Now just test your understanding. Now let's move to this example. It's 11th one. Now test your understanding, it's very important. So again this has a range, this part of the orange has a range r 0 to r. There is no confusion about that, because finally some part lies on this axis, and then some part increases, we will come out to the surface which has the radius of r. Now what is theta? Now what is the theta? Now tell me. So basically if we consider here the part here, it is making angle theta 1. You consider it because it's a part of the sphere. So it's every point is making angle theta 1. It's a bit difficult to imagine it in the 3D, but you can consider the again the umbrella part. Just open it this much, and consider two side by, consider this much of area, So basically all these points are making angle these points are making angle theta 1. Okay, and this is making angle theta 2, because this is differently opened the umbrella. You open it first this much, then you open it like this much, and imagine the part. So initially actually it is from theta 1 to theta 2. I know, but I'm not able to make you imagine this thing, but you can imagine yourself. This part is making angle theta 1 every point on it. Okay, and from here it is making theta 2 different angle. Okay, and what is phi 1 is again phi 1 to phi 2. Okay, because finally it is coming downwards. So you can consider it from phi 1 to phi 2. Okay, I hope you're able to make it understand. I'm able to make you understand certain things. Now you can, it's all about the imagination. Okay, so finally now we can write a given vector dl vector, any vector, in terms of r, theta and phi. So let's go. I think let's start this thing from the next video. I believe I need a next video on it. Thank you so much.